The OSGi specification describes a modular system and a service platform for the Java programming language that implements a complete and dynamic component model, something that does not exist in standalone Java VM environments. Applications or components, coming in the form of bundles for deployment, can be remotely installed, started, stopped, updated, and uninstalled without requiring a reboot. Management of Java packages classes is specified in great detail. Application lifecycle management is implemented via APIs that allow for remote downloading of management policies. The service registry allows bundles to detect the addition of new services, or the removal of services, and adapt accordingly. The OSGi specifications have evolved beyond the original focus of service gateways, and are now used in applications ranging from mobile phones to the open-source Eclipse IDE. Other application areas include automobiles, industrial automation, building automation, PDAs, grid computing, entertainment, fleet management and application servers. Sponsoring organization, the OSGi Alliance, formerly known as the Open Services Gateway Initiative, now an obsolete name, is an open standards organization founded in March 1999 that originally specified and continues to maintain the OSGi standard. Specification process: the OSGi specification is developed by the members in an open process and made available to the public free of charge under the OSGi specification license. The OSGi Alliance has a compliance program that is open to members only. As of November 2010, there are 7 certified OSGi framework implementations. A separate page lists both certified and non-certified OSGi specification implementations, which include OSGi frameworks and other OSGi specifications. Architecture: any framework that implements the OSGi standard provides an environment for the modularization of applications into smaller bundles. Each bundle is a tightly coupled, dynamically loadable collection of classes, jars, and configuration files that explicitly declare their external dependencies. The framework is conceptually divided into the following areas: bundles. Bundles are normal jar components with extra manifest headers. Services. The services layer connects bundles in a dynamic way by offering a publish-find-bind model for plain old Java interfaces or plain old Java objects. Services registry, the application programming interface for management services. Lifecycle, the application programming interface for lifecycle management for bundles. Modules, the layer that defines encapsulation and declaration of dependencies. Security, the layer that handles the security aspects by limiting bundle functionality to predefined capabilities. Execution environment, defines what methods and classes are available in a specific platform. There is no fixed list of execution environments, since it is subject to change as the Java community process creates new versions and editions of Java. However, the following set is currently supported by most OSGi implementations: CDC 1.0/Foundation 1.0, CDC 1.1/Foundation 1.1, OSGi Minimum 1.0, OSGi Minimum 1.1, JRE 1.1. From J2SE 1.2 up to J2SE 1.6. Bundles. A bundle is a group of Java classes and additional resources equipped with a detailed manifest.mf file on all its contents, as well as additional services needed to give the included group of Java classes more sophisticated behaviors, to the extent of deeming the entire aggregator component. Below is an example of a typical manifest.mf file with OSGi headers. Bundle name, Hello World, bundle symbolic name, org Wikipedia Hello World, bundle description, a Hello World bundle, bundle manifest version, 2, bundle version, 1.0.0, bundle activator, org Wikipedia activator, export package, org Wikipedia Hello World. Version equals 1.0.0, import package, org OSGi framework. Version equals 1.3.0. The meaning of the contents in the example is as follows: bundle name, defines a human-readable name for this bundle, simply assigns a short name to the bundle. Bundle symbolic name, the only required header, this entry specifies a unique identifier for a bundle. based on the reverse domain name convention. Bundle description, a description of the bundle's functionality. Bundle manifest version, indicates the OSGi specification to use for reading this bundle. Bundle version, designates a version number to the bundle. Bundle activator, indicates the class name to be invoked once a bundle is activated. Export package, expresses which Java packages contained in a bundle will be made available to the outside world. Import package, indicates which Java packages will be required from the outside world to fulfill the dependencies needed in a bundle. Lifecycle. A lifecycle layer adds bundles that can be dynamically installed, started, stopped, updated and uninstalled. Bundles rely on the module layer for class loading but add an API to manage the modules in runtime. The lifecycle layer introduces dynamics that are normally not part of an application. Extensive dependency mechanisms are used to assure the correct operation of the environment. Lifecycle operations are fully protected with a security architecture. Below is an example of a typical Java class implementing the bundle activator interface. Services, standard services. The OSGi Alliance has specified many services. Services are specified by a Java interface. Bundles can implement this interface and register the service with the service registry. Clients of the service can find it in the registry, or react to it when it appears or disappears. The table below shows a description of OSGi system services. The table below shows a description of OSGi protocol services. The table below shows a description of OSGi miscellaneous services. Organization. The OSGi Alliance was founded by Ericsson, IBM, Motorola, Sun Microsystems and others in March 1999. Before incorporating as a non-profit corporation it was called the Connected Alliance. Among its members are more than 35 companies from quite different business areas, for example Adobe Systems, Deutsche Telekom, Hitachi, IBM, Macrowave, NEC, NTT, Oracle, Orange SA, ProSys, Salesforce.com, Siemens, Software AG and TIBCO Software. The Alliance has a board of directors that provides the organization's overall governance. OSGi officers have various roles and responsibilities in supporting the Alliance. Technical work is conducted within expert groups chartered by the board of directors, and non-technical work is conducted in various working groups and committees. The technical work conducted within expert groups include developing specifications, reference implementations, and compliance tests. These expert groups have produced 5 major releases of the OSGi specifications. Dedicated expert groups exist for the enterprise, mobile, vehicle and the core platform areas. The Enterprise Expert Group is the newest OSGi and is addressing enterprise/server-side applications. In November 2007 the Residential Expert Group started to work on specifications to remotely manage residential home gateways. In October 2003, Nokia, Motorola, IBM, ProSys and other OSGi members formed a mobile expert group that will specify a MIDP-based service platform for the next generation of smart mobile phones, addressing some of the needs that CLDC cannot manage, other than CDC. MEG became part of OSGi as with the 4. Community. In 2003, Eclipse selected OSGi as the underlying runtime for the plugin architecture used for the Eclipse Rich Client platform and the IDE platform. Eclipse itself includes sophisticated tooling for developing OSGi bundles and there are a number of other Eclipse plugins aimed at supporting OSGi behavior. There is a vibrant free software community revolving around the OSGi specification. Some widely used open-source implementations are Equinox, Apache Felix and Nopala Fish OSGi. Regarding tooling, build system support and testing, the OPS4J-PAX projects provide a lot of useful components and expertise. Specification versions, OSGi Release 1, May 2000, OSGi Release 2, October 2001, OSGi Release 3, March 2003, OSGi Release 4. October 2005/September 2006, Core Specification, October 2005, Mobile Specification, September 2006. OSGi Release 4.1 May 2007, OSGi Release 4.2 September 2009, Enterprise Specification, March 2010. OSGi Release 4.3 April 2011, Core, April 2011, Compendium and Residential, May 2012. OSGi Release 5, June 2012, Core and Enterprise, June 2012. New in OSGi Release 4, the new features of OSGi R4 in brief are as follows. New modularization capabilities providing enhanced encapsulation of networked services that can share a single virtual machine. Modularized class sharing and hiding of implementation details. Methods for handling multiple versions of the same class as so old and new applications can execute within the same VM. Localization of OSGi bundle manifests enabling service deployment anywhere. Enhancements in security and policies. The new Conditional Permission Admin service provides an elegant and simple way to manage networked services securely. It also supports dynamic policies that can depend on external conditions. Combined with R4 support for digital signatures, this provides a central security solution to large deployments of products using the OSGi service platform. A declarative services specification that addresses memory footprint issues that can prevent small embedded devices from using a service-oriented architecture to support multiple applications. Additionally, it significantly simplifies the service-oriented programming model by declaratively handling the dynamics of services. Compatibility with Release 3, requiring no changes for existing OSGi bundles, applications, or services. New in Release 4.1, OSGi R4.1 was a minor revision intended to clarify certain aspects of bundle initialization and loading in order to improve third-party usage. It added no new services or major features. New in Release 4.2, OSGi R4.2 was a significant release that added several new services and capabilities, including framework launching, standardized means to launch OSGi from various providers. Remote services, allows the exporting of services to remote VMs, blueprint service, dependency injection and inversion of control that allows external configuration of bundle dependencies, bundle tracker, track and respond to changes in bundle presence and state, service hooks, allow introspection and behavior modification of service calls to inject security or dynamicism, conditional permissions, support negative permissions, forbidding specific actions instead of just allowing them. More information can also be specified in each bundle header, such as license information, MIME types and icons. Additionally, changes to declarative services allow the easier setting of permissions. Finally, OSGi bundles can now have their return values read. OSGi R4.2 also introduced a new specification release for the enterprise including support for web applications, a standardized format for building OSGi web applications packaged using the WAR file format. JPA service provides a reliable standard mechanism to use the Java Persistence API in OSGi. JNDI service allows integration of the OSGi service registry and the Java naming and directory interface. JDBC service provides an OSGi lifecycle-aware mechanism to obtain connections to an external database. New in Release 4.3, generics, the framework now uses JDK5 generics in several places. However, Java 1.4 can still be targeted using Source 1.5 target JSA14 switches to JAVAC. Capabilities, a set of attributes in a namespace in a module's meter information, such as OSGi wiring package export package. Requirements, a filter expression over the attribute set of a capability, such as OSGi wiring package import package. Adapt, replaces framework services. Adapts bundle to another type. Replaces package admin and start level services with APIs which a bundle can be adapted to. Weaving hook, the weaving hook services allows load time bytecode weaving. Resolver hooks and bundle hooks, replaces the nested frameworks and composite bundles proposal with low-level capabilities to influence requirement capability matching. Service event listener hook, replaces service event hook with finer-grained event delivery control. New in Release 5.0, new in Core Release 5, Resource API for modeling generic capabilities and requirements. Version range class. New in Enterprise Release 5, related RFCs and Java specifications, RFC 2608, SumGi, SumJCPJSR8, SumJCPJSR232, SumJCPJSR246, SumJCPJSR249, SumJCPJSR277, SumJCPJSR291, SumJCPJSR294, related standards, MHP/OCAP, Universal Plug and Play, DPWS, ITUTGHN, LonWorks, CORBA, Cibooz, EHS/CECED Chain, Java Management Extensions, projects using OSGi, Apache Errors, Blueprint Container implementations and extensions of application-focused specifications defined by OSGi Enterprise Expert Group. Apache Carafe, an OSGi-based runtime that provides a lightweight container onto which various components and applications can be deployed. Apache Felix, an implementation of the OSGi R4 service platform and other OSGi-related technologies. Apache Sling, OSGi-based applications layer for JCR content repositories. Atlassian Confluence and JIRA, the plugin architecture for this enterprise wiki and issue tracker uses OSGi, Business Intelligence and Reporting Tools Project, Open Source Reporting Engine, Cytoscape, an open-source bioinformatics software platform, Data Nucleus, Open Source Data Services and Persistence Platform in Service-Oriented Architectures, DOTCMS, Open Source Web Content Management, EasyBeans, Open Source EJB3 Container, Eclipse, Open Source IDE and Rich Client Platform, Eclipse Virgo, Open Source Microkernel-Based Server Constructed. Of OSGi bundles and supporting OSGi applications, Event Insight, SAP Business Objects Complex Event Processing SDN, Glassfish, Application Server for Java EE, Fuse ESB, a productized and supported release of Service Mix 4. GX Web Manager Community Edition, an enterprise web content management system based on OSGi, Spring and JCR, IntelliJ, Java IDE and Rich Client Platform with Free Community Edition, JBOSS, Red Hat's JBOSS Application Server, Jonas 5, Open Source Java EE5 Application Server, JOSSO2, Attribution's Open Source Standards-Based Identity and Access Management Platform, NetBeans, Open Source IDE and Rich Client Platform, Nuxio, Open Source ECM Service Platform, Open Daylight Project, OpenEJB, Open Source OSGi-enabled EJB 3.0 container that can be run both in standalone or embedded mode, OpenWRM, Open Source Software Simulation of C. elegans, via the dedicated Geppetto modular platform, Parimas Service Fabric, an autonomic OSGi-based private cloud runtime that supports Blueprint, declarative services and Scala-based applications. Spring Source DM Server, open source microkernel-based server constructed of OSGi bundles and supporting OSGi applications, WebLogic, Oracle WebLogic Application Server, WebSphere, IBM WebSphere JEE Application Server, WebMethods, Software AG WebMethods, WSO2 Carbon, base platform for WSO2 a Euro unregistered trademark S enterprise-grade open-source middleware stack. Current framework implementations, see also, OSGi specification implementations, references. Further reading. External links, official website, ERID of 2008, Architecture, OSGi Now and Tomorrow, information on Java software components in the form of enterprise Java beans and OSGi bundles, Chinese OSGi community, frequently asked questions, OSGi developer mail list, OSGi Open Forum and Discussion Central, Eclipse Equinox Article Index, articles on an open source OSGi implementation, OSGi Users Forums, Belgium, Brazil, China, France, Germany, Japan, Korea, Spain, Sweden, UK and soon in Italy.